video for, I will go through the question, are small schools, or do the, whatever, this one, do small schools perform better than large ones? I'll go in detail, and if you happen to have this data table, you're welcome to use what I do, to reuse what I do in that video as a part of your term paper. So then we go down here to chaining methods. Down here is the focus of Unit 6, as I talked about Tuesday in class. This is the build, filter, and order steps. And let's try to get some of this working with the animal data set that you are used to. So from here, as you build column, as you filter, as this long mumbo-jumbo line, we paste this onto our starter file, onto Pirate. Let's see what happens when we run. I think we get an error. It's likely that you will have the same error as I did too. Name tag is not defined. So that is a function that we've likely skipped over because we did not cover units 4 and 5. We'll come back to that later. I think if you read over that, it will make sense to you. But we're focusing on the stuff that is harder, the statistics portion of it. So the name tag function, right? So what does that look like? We have to define this. So we go up here, we'll borrow some code maybe from isYoung, maybe even the contract down here. So we get this error. So it says it's unbound, so we didn't write that just yet. The name tag function looks like so. Name tag, you're going to take an animal, and then you're going to return an image. Why is it an image? Well, it's going to be a big version of their name in red text, for example. You could choose other kinds of colors if you so desire. Name tag. Okay. So again, I'm going over in real time how I would modify a function so that it achieves like how do I create my own functions? Consumes a row of animals and makes a text version of their name. It is going to be red. The examples are kind of hard to test. I'm not sure what the return type would be there. So maybe we'll just like so. I'm not sure what to put. So perhaps we'll delete this and come back to it, rather than delete, comment it out. So down here we have an animal, we look up its name, okay, and we're not going to do any kind of comparison. Instead, we're going to apply this to the text function, okay. If you forgot how the text functions works, you can go to your student workbook, jump to page 65, there's text, so we need a string. This is going to be our animal name. Then we have a number and the color. So arbitrarily, we'll pick the number 20, comma 20, and then it's going to be red. That's the name tag function. It's different than the other ones we do. We give it a name, and we pass that in or use it in the text function. It's a function in a function. And so now, I think, let me run this code. Oh, comment that out too. So I don't know how to check if a proper image has been generated. I'll come back to that later, or maybe we won't. And down here, isYoung as passed. We didn't have any examples, but now when we look at animals dash table, let's see if anything changed. I'm going to scroll over. Way over here. It doesn't look like there's a new column just yet. Why is that? Well, we didn't save this table, right? Let's call this new animals table. Okay, and that's going to have that extra column. It uses the build column feature. So let's click run. We made changes on the definition side. In order to see those changes, we have to click run again. New underscore animals dash table. Now, when we scroll on over, we'll see, there it is. Here are the images. Right, those are their labels. Why is it called label? Well, when we built the column in our code, you can see, right, there's the new column name. This is the data, right? That's the name tag, a bunch of images, and we'll go over the rest of the stuff, right? Notice it's not like 31 animals. It's only like 15-ish animals, 18-ish animals. And we ordered by species, so all the cats come before the dogs. We'll break this one line of code down in detail. And what your Unit 6 code or lesson walks you through is that, okay, this bunch of code, it's kind of messy. So Pirate works just the same. If you, before the periods, you make a new line for each of these things. So you press enter. So this makes it a lot more readable. You can see, we built a column, then we're going to filter, then we're going to order by. And this order does really matter, right? There's the, maybe we'll change this to proper animals table, okay? Build, filter, order. And now we'll see what happens when we don't do this properly, right? Here's going to be the first improper. And maybe we'll try to filter first, then build the column, right? There may be some unintended side effects. And maybe then we'll try to doing it again. We're just experimenting with what happens when we mix up this order. Maybe we'll order it first, then filter, then build the column. Okay, so let's see, run. Okay, so here's the proper animals table. Take a look at that. Okay, we have 18 animals that have that label that's organized. Cats come first, then by dogs, and we notice they're all fixed. Let's see what happens when we type in first improper table. Keep going. First improper. All right, we click enter. Here looks like we're okay. Nope. First improper. Cat. Great. Still fixed. And off to the very side, we shall see animals. Okay, so first improper table. Looks like that was actually okay when we filter, build, and order by. Let's check the second improper. Looks like this one's okay too. So my two other examples where I mixed up the filter, build, and order by functions didn't seem to matter in this case. Yeah, but there are cases where it will matter, and that's what pages 36 and 37 take you through. So on page 36 of your student workbook, right, let me zoom out. In this page, I worked through block 7 on this page, and then block 8 we went through page 38. Order does matter, because sometimes you're going to get an error. It's not what you intended on doing, and it's not the data you wanted to study, okay? So if you want to review that, you can pause and take a look. Here are the keys to those respective things for you to review. Here's the answer key to page 37. You can pause and take a look at the blue arrows. I even make it bigger for you. Right? This is 36. And then down here, we went over this in block 8. Here's 37, so you can check over your work. Back to here. This section, both classes I talked about the racist faucet. So remember that example when a lighter-skinned white person goes over to wash their hands, it detects them, but when a darker person, right, like an African-American guy or a darker-skinned Latino person comes over and tries to use the sink, it doesn't work for them. Like, why? So that was bad sampling. You only took lighter-skinned people, and thus your faucet, your hands-free faucet, only responds to lighter-skinned people. That's not good. Your sampling might have taken enough people, but it doesn't represent the entire population. So that's one key idea there. And this other part has you like address it, okay? So if that company made a racist sink and they tested and like made the technology using lighter skinned people, why did they then like start testing in like a really white dominated like part of the US, for example, and then they just got more data, or their test cases just confirmed like their working data, their test cases. Why didn't they take them to a more diverse area, like in San Francisco, for testing that out, putting it like in different neighborhoods, and then seeing if they get the same kind of output, right? Whether or not water comes out of this faucet. The section down here walks you through some of those examples. Like, okay, we want to here, right? We have a function that shows only kittens. So how do we know our function's working? Well, you have to give that function a table or some data that includes like kittens, young cats, and maybe some young dogs, and throw in some like puppies in there, right? You have to make sure your function works and it's not unintentionally biased in that ways. There's this worksheet on page 38 that you can walk through that says that. So we have fixed cats. So it consumes a table of animals, produces a table only containing cats that have been fixed, sorted, youngest to old. Well, you have to give it then some not fixed cats. You have to get some dogs that are fixed. You have to give it some things that have age so that you know that ordering is correct, like for sure a really old dog, really young cat, so on and so forth. And here are the answers to page 38. Should match. Yep. Animals that are cats that are not, and animals that are not cats, cats that are fixed, and cats that are not fixed. That's how we validate and test that this function's working. Sure, we trust it at first because we wrote it, but we want to verify. And then here's the answer to the second one. What happens if you had a old dog's name tag function? And then see how you can test that, and you can check your answer there. So that ends the overview for Chapter 6, Unit 6.